Okay, this is Mr. Osmeyer, and I've already went through some review of solving equations with you back from Chapter 3. This will be Chapter 6 for our classes. Starting in 6.1, we're going to be solving inequalities, and in this section, they all involve solving by adding or subtracting from both sides. First off, you need to know what an inequality is. The reason we reviewed solving equations can be a very similar process, but the inequalities are always going to, instead of an equal sign, they have a less than sign, a greater than sign. This with a line underneath it will be a less than or equals to, and a greater than or equal to. One of those four symbols are going to be in each one of our problems, and that's what makes it the inequality. Sorry about the gray boxes that will appear on some of them. You just have to ignore that. There's not actually a line underneath these. Okay, to get started on number one, the problem is x plus 14 is greater than negative 2. I think it helps you to read it out loud so you or get used to saying what that symbol is representing. The directions tell us to solve it, and then after we've solved it, we're also going to graph it on a number line. So I'm going to go ahead and freeze this, grab a pen. Just like an equation, the first thing we would do to get x by itself, that's what the solving process is, would be to move that 14. We're going to move it by subtracting 14 on both sides of our inequality. The x is still there, 14 is gone. We have a greater than symbol and negative 2 minus 14. Think about it. Try it on a calculator if you need to double check. And you get a result of negative 16. So then multiple solutions are going to make this inequality true, unlike an equation with this one variable to have one solution to it. Any number that is greater than negative 16 is going to work. So negative 15 is greater than it. Negative 2 is greater than it. 0 would make this equation true. 1, 2, 3, 4, 5. Any of those positive numbers are also going to make it true. You can think about that if I plugged in a 5 or a 6 right here. 6 is greater than negative 16. Read it out loud. You know that's a true statement. And we're going to try and represent all of those solutions to this inequality by drawing it on a number line. We made number lines in the past. For our sake, this chapter, when I'm grading things, I'm just going to require you to show at least 3 numbers. The number we're starting with and dealing with in our answer is negative 16. I like you to put that in the middle. Just choose one number smaller than negative 16 and one number bigger than negative 16. It's convenient to go 1 unit away on each side, I think. Once you know you've made it long enough, go ahead and put your arrows on the end of a number line. And we are going to show that we're starting at the negative 16 with a circle here. We're going to leave that circle open because we're going to shade every number that represents a solution. And negative 16 doesn't actually represent a solution, but numbers right up into it. And I said anything in the negative 15 direction, negative 14, negative 13. So anything to the right of this represents a solution to that inequality. So I'm going to shade on the number line, and then I'm also making my arrow nice and bold so we know this pattern continues to the right. Any number to the right on that number line is also going to make it true. So we just solved the inequality and we drew a graph on the number line. Remember, the purpose of the number line is representing all of the solutions. Multiple solutions make this true. If you're dealing with w minus 8 is less than or equal to negative 4, just like an equation, you want to get your variable by itself, add the 8 across, since it's part of subtraction right now. Just going to say w is less than or equal to negative 4 plus 8 gives you a positive 4. So w is less than or equal to 4 is your solution. Represent all of the values that make that true. I've got a number line, arrows on the ends. I'm putting the 4 in the middle and just any number smaller than it. I'm going 1 unit smaller and 1 unit bigger. So my number line shows a 3, 4, and a 5. We're starting with the 4. And I'm actually going to fill in this circle because 4 does make it true. 4 is less than or equal to 4. That's a true statement because it is equal to. So because it's part of the solution set, I'm shading in that area. And then numbers that make it true, 3 would make this true. 2 would make it true. 1 would make it true. So further to the left. So you shade in the direction of all of the solutions. That pattern continues further and further to the left forever. So we have a bold arrow on the left side to represent that. So solving, I'm not too worried about. I'm confident you guys are going to be able to do that right. Be careful when you're making your number lines. You're going to have an open circle with a greater than or with a less than sign. It's the or equal to part, the line underneath right here, that is going to fill in the circle for you. I say if you have a number on each side, that's a detailed enough number line for me. The shading represents any solution, so just think carefully. Does negative 17 make this true? No. Does negative 15 make it true? Yes. That's the reason we shade in that direction. Okay, after solving those inequalities and graphing them, the next type of problem we're going to face in the same section is going to be writing an inequality for a sentence, and then you're going to solve it after that. So you're going to see the words. Basically, you're going to have to turn those into symbols and go ahead and solve. Before we get started on that, you should hopefully remember from the first semester many of those keywords, what phrases mean add, subtract, what phrases mean equals. We had is or is equal to, and we're going to translate that in with our inequalities. Many of those are going to start with the word is as well. Let me go ahead and insert some of the phrases in here. Naturally, you would read some of these as is greater than, is less than, is greater than or equal to, is less than or equal to. But there's phrases past those that I want to plug in here. Some of the ones I just said, and you want to look further. For instance, instead of saying is greater than or equal to, you could say is at least. That's a phrase you've heard. You might not have realized that it relates to the inequality symbol of greater than or equal to. Go ahead and check these out, and maybe if you need to write them down in your notes, go ahead and get that done. They're going to help us with problems like the one below here for problem number 3. So it tells us to write the inequality and solve it. So we first focus on getting the inequality written down. It says 40 less than a number. Kind of read each part of the sentence piece by piece and take it from there. When you read 40 less than a number, notice how it does not say is less than. So just like in chapter 1 and throughout all of the first semester, that's just a subtraction right there. 40 and a number are, one of them is being subtracted from the other. Anytime you see the less than, remember the order gets switched. So when you see a number, that just means pick some letter to represent it. We generalize it can be any number. Our subtraction with 40, so we're taking 40 away from that number. That's what it means. And here is more than. It starts with the word is, so you know it's going to have to do with some of our inequalities. You just don't know which one right away. Is more than, that one's fairly obvious. That's a greater than symbol. We had it typed up above. And it is more than 8. So you have your inequality written down. In order to solve it, you just need to move that subtraction to 40, get rid of it, so you add 40 to both sides, add 40, and the solution to your inequality is x is greater than 48. Any number that's bigger than 48.